So in this video we are going just over a few more examples of changing exponential statements to logarithmic statements and vice versa. And we had already a couple ones, and we're just gonna go a few more so you see different ways it can look. And then we will, after that in subsequent videos, then go over actually more of solving equations. So in this video we are actually just going to utilize our newly found logarithm definitions to change it into the other statement. So I'm gonna remind ourselves one more time of our definition, and that was logarithm to the base a of x equals y if and only if a to the y's power equals x. So let's look at our first example, a 3 to the t's power equals 5. Now our base, remember, stays the same, so our base is 3, therefore we are talking here about a logarithm to the base 3, and then logarithms are always basically solving for the exponents. So logarithms are exponents. That means when we write here, we know that this will be t equals the exponent equals and can be expressed as the logarithm to the base 3, and then the only number that's left is 5. And that's all we're going to do here. And then our next example, I'm going to go down. So I have again similar scenario. I have an x in the exponent. So if I rewrite it, I know already that I am solving for the exponent. That's why we invented logarithm. And that equals, so then I write my logarithm. Now the base here is a little unusual, but can be, is 1/4, and the number then is 6. So again, that's it. Now when we are going to see, same scenario, I start with my exponent is what I would like to find out. Now in this case, my logarithm, I'm going to write it out once, is to the base 10, and therefore of 7. However, when we write the base 10, we don't actually have to write the base. So all we have to write here is log 7, often said, so logarithm of 7. And that's a common logarithm. Now, so we had the common logarithm now. Now we have the base e in our example, next example. So that way we know it will be the natural logarithm. So our exponent in this case is actually 2t. So I'm going to write it out one more time. Logarithm to the base e, and then therefore of 5. And we rewrite that with ln of 5. So if we were solving for t, we would still divide by 2 at the end, but in this case we are not going to do that. We're just leaving the rewriting of it. I should have actually up here rewritten my m, and I'm going to rewrite here my 2t, because if it's we're starting as an equation, we are ending as an equation. It's different when we are simplifying an expression. And now after this we are still going to do it the other way around. I'm going to one more time also restate my definition, so you can keep that in mind. And so now we are ready to tackle it the other way around. So we're starting this time with a logarithmic expression or statement, and we are wanting to find the equivalent exponential statement. So we again will be focusing on our base. That's always very crucial that remains the same. So our base here is 3. Now, if what was our output, the logarithm equals x, that means that will now be our input. And what was our input will now be our output, that is 5. And voila, I found my equivalent statement. I'm going to go one down to B. I'm going to do the same thing again. I again have my base. My base is very clearly the small number at the logarithm sign. And then what is now my answer is negative 3 will now be my input. So it's 2 to the negative 3, and that equals y plus 1. So just switching places. And again, if I now here would like to solve all the way for y, I would minus 1 on both sides, but that's not the point. Just like in A, we actually just in a way made it more complicated, but this is just to kind of practice going back and forth. And then for C, so now we just have log, and we have to remember that that means we're having base 10. So 10 to the power of 1/2 equals x. Now here I would like to remind us that the power of 1/2, so any rational power, refers to a square root. So you can also rewrite that as the square root of 10 equals x. And then last but not least, now we're coming to an ln. And ln again was our base e. So we are rewriting it with e and then to the power of 5, because the logarithm told us what our exponent is. And then what was our input is now our output. So in this case, because the x was the input with the logarithm, we are actually now having it as an output and would be able to solve it if we plugged it into our calculators. So we have done some examples just rewriting it, and you're now going to use it where you're actually starting more to solve in the next video.